From a construction mistake that accidentally created one of the most iconic landmarks in human history to tragic building collapses that claimed hundreds of lives, here are 5 construction projects that didn't go as planned. Throughout history, construction has reflected humanity's ambition. Civilizations have always tried to build higher, wider, and stronger structures to prove what's possible. From ancient stone towers to modern glass skyscrapers, every era has pushed engineering to its limits. But construction is unforgiving. A building doesn't care about deadlines, press releases, or budgets. Gravity never negotiates. Materials don't forgive poor maintenance. Soil doesn't respect optimism. When safety margins are ignored, when warnings are dismissed, or when profit is placed above sound engineering, the consequences can be devastating and irreversible. Some failures become landmarks admired for centuries. Others become disasters that should never have happened. These are the stories behind 5 projects that remind us why engineering decisions matter. Before we begin, there's a pattern that shows up again and again in construction failures. It's rarely one single mistake. Instead, it's usually a chain of small decisions. A shortcut here, a rushed inspection there, a change made without a full structural review, a warning that gets handled later. And then one day, the structure reaches a breaking point. Engineers often describe this as a Swiss cheese model. Each layer of safety has holes. Most of the time, the holes don't line up. But when they do, when multiple failures align, the outcome can be sudden and catastrophic. And one more thing, sometimes a failure isn't a total collapse. Sometimes it's a project that becomes unusable, dangerously expensive, permanently delayed, or structurally compromised. Those failures matter too, because they reveal how fragile mega-project planning can be when systems, budgets, and oversight break down. Number 5. In June of 2009, residents in Shanghai woke up to an unbelievable sight. A 13-story residential building was lying completely on its side. The structure had not collapsed into rubble. It had tipped over almost perfectly intact, like a giant concrete domino that had quietly fallen during the night. This was the Lotus Riverside Complex. The project was a luxury apartment development nearing completion. On the surface, everything appeared normal. The building used modern, reinforced concrete construction. It looked like the kind of structure people expect to last for generations. But beneath the building, a critical mistake was unfolding. Workers were excavating soil to create an underground parking garage. Excavation by itself is normal. The problem was what happened next. Instead of hauling that excavated soil away, it was piled directly beside the building. At the same time, heavy rainfall weakened a nearby riverbank. The ground became saturated, soil lost strength, and pressure began to shift. Here's the key engineering issue. Foundations are designed for specific forces. Piles are typically built to carry enormous vertical loads, the weight of the building pressing downward. But when soil starts pushing sideways and the pressure is uneven, piles can be forced to take lateral loads they were never designed to resist. In this case, the soil shift created massive lateral pressure, and the foundation piles sheared off. With its foundation compromised, the entire building tipped over. One construction worker lost his life. What disturbed engineers worldwide was how clean the failure appeared. The building didn't crumble, it didn't explode, it simply fell intact, revealing how a foundation failure can behave like a hinge. And that's the nightmare scenario for any engineer, when a structure fails, not because the building is weak, but because the ground beneath it is destabilized. It also shows how construction sites can be dangerous even when the main building looks finished. A project can fail at the very end if the last steps aren't controlled. The big lesson from Lotus Riverside is that construction is a system. Excavation, drainage, soil storage, riverbank stability, and inspection schedules all interact. If one part is treated casually, it can undermine everything else. That's why professional sites enforce strict rules on where soil can be stored, how water is managed after storms, and how ground movement is monitored in real time. And if there's a human lesson here too, it's this. The most expensive parts of a building aren't always the visible ones. The hidden work, foundations, soil, drainage, is often what decides whether a structure survives. Number 4. Rising above the coastal city of Benidorm, Spain, The Intempo Skyscraper was designed as a symbol of luxury and ambition. Two sleek towers connected by a massive diamond-shaped crown, panoramic views of the Mediterranean, high-end apartments marketed to wealthy buyers. But hidden behind the glass facade was a stunning oversight. As construction progressed, reports emerged that the building did not have enough elevators to serve its height. In simple terms, the skyscraper was too tall for its own infrastructure. That might sound like a small problem, until you picture living on the 40th floor with limited elevator capacity. Elevator planning isn't just about convenience. It affects building codes, accessibility, emergency response, fire strategy, and daily livability. A tall tower is essentially a vertical city, and elevators are the streets. Fixing an elevator mistake late in construction is brutal. Elevator shafts are not decorative. They are structural cores that interact with floor layouts, utilities, mechanical systems, and load paths. Adding or expanding shafts can require rerouting plumbing and electrical systems, altering layouts, and reinforcing structural components around new openings. Even worse, these fixes often happen after contracts are signed, budgets are locked, and buyers are expecting delivery. That's when a planning mistake becomes a financial crisis. Costs soared, timelines slipped, investors withdrew, construction stalled multiple times. Intempo became infamous across Europe as an example of how a high-profile megaproject can spiral when coordination breaks down between architecture, engineering, and real-world execution. It's a reminder that building tall is not just stacking floors. It's designing a complete system: vertical transport, ventilation, safety, maintenance, and operations for decades. One of the biggest takeaways here is that megaprojects need coordination, not just talent. You can have brilliant architects and skilled engineers, but if teams don't communicate, errors slip through. That's why many large developments use repeated design reviews, clash detection, and multi-team sign-offs before construction ever begins. And there's a business lesson too. When a project is marketed as luxury, expectations are unforgiving. Delays, redesigns, and uncertainty can damage trust, scare away buyers, and turn a landmark into a cautionary tale. Number 3. The next project was once celebrated as a marvel of modern architecture and a tourist attraction that seemed almost impossible to build. Located in Berlin, the AquaDom was the largest cylindrical aquarium ever constructed, a massive acrylic tank holding more than 1 million liters of water, thousands of tropical fish, a glass elevator running straight through its center so guests could ride upwards surrounded by marine life. For years, it looked like a triumph, a fusion of engineering, design, and spectacle. Then, in December of 2022, disaster struck. Without warning, the AquaDom ruptured. More than 1 million liters of water exploded into the hotel lobby and surrounding streets. Glass debris was thrown across the area. Nearly every fish inside was killed. Emergency crews described chaos, flooding, shattered material, and severe damage to the surrounding structure. So, what went wrong? Investigations pointed toward long-term material fatigue. When you build extreme structures, the challenge isn't only day 1, it's year 10. Acrylic and other transparent materials can experience stress over time, especially under constant pressure, temperature swings, vibration, and micromovement. And unlike traditional concrete tanks, a display tank must stay transparent and aesthetically perfect. That limits how it can be reinforced and how imperfections can be tolerated. Tiny flaws can grow slowly, almost invisibly, until they reach a critical point. The AquaDom wasn't a failure of imagination. It was a reminder of something the public often forgets. Maintenance is engineering. Lifespan is part of design. And spectacular structures often demand spectacular inspection routines, careful monitoring, and costly upkeep. It also shows how modern, experienced architecture can introduce new risks. When a building becomes a spectacle, the structure is often operating closer to its limits. If inspections or upgrades fall behind, the failure can be sudden. A second lesson is that engineering doesn't end at opening day. Owners need long-term monitoring plans, replacement schedules, and realistic budgets for upkeep. When a structure is unusual, the maintenance must be unusual too. Otherwise, the risk grows silently until one day the system fails. Number 2. Not every construction mistake ends in tragedy. Some become legends. Construction of the Leaning Tower of Pisa began in the 12th century. Almost immediately, builders noticed the tower was sinking. The foundation had been laid on soft soil made up of clay, sand, and silt, a risky choice for a heavy stone structure. By the time the third floor was completed, the tower had already begun to lean. At that point, the builders faced a terrifying reality. The structure was already unstable while still unfinished. Construction paused for decades due to wars and political instability. Ironically, those delays likely saved the tower by allowing the soil beneath it to settle gradually rather than suddenly. Over time, builders attempted to compensate by making upper floors slightly taller on one side, essentially trying to curve the tower back into balance. The result was a structure with a subtle bend, not just a simple lean. Over centuries, the lean worsened. By the late 20th century, the tower was dangerously unstable. Engineers feared it could collapse within a lifetime. A massive stabilization project began. Soil was carefully removed from beneath the high side to reduce the lean. Counterweights were installed. Anchors and supports controlled movement. The goal was not to make the tower perfectly straight, that would destroy its identity, but to make it safe. Today, the Leaning Tower of Pisa stands safely, not as a failure, but as one of the most recognizable landmarks on Earth. A mistake that became an icon, and a reminder that geotechnical engineering can decide the fate of a structure before the first stone is even placed. The final lesson from Pisa is simple. The ground matters. Even perfect stonework can't overcome poor soil conditions. Modern projects spend huge budgets on soil testing, ground improvement, and foundation design for this exact reason. Because if the foundation is wrong, everything above it becomes a gamble. Number 1. The final project on this list is one of the deadliest construction failures in modern history. This one is not a quirky accident. It is a tragedy caused by a chain of decisions where warnings were ignored and safety was treated like a cost. The Sampoong Department Store was located in Seoul, South Korea. Originally designed as an office building, it was later converted into a large department store. That change alone should trigger major structural reanalysis, because offices and department stores have different load requirements. Department stores involve heavier live loads, dense crowds, stocked inventory, large open floor spans, and intensive mechanical systems. And when you add last-minute structural changes, the risk multiplies. During construction and modification, critical support columns were removed to make room for escalators. Heavy air conditioning units were placed on the roof, far beyond what the structure was designed to support. These changes weakened the load path, the invisible route that carries weight safely down into the ground. Cracks began appearing. Employees reported loud noises and visible structural damage. Engineers reportedly warned the building was unsafe. Management ignored the warnings. On June 29, 1995, the building collapsed in less than 20 seconds. More than 500 people were killed. Nearly 1,000 were injured. It was not an unavoidable accident. Investigations pointed to corruption, cost-cutting, and deliberate negligence. The Sampoong disaster became a defining example of what happens when safety regulations are not enforced and when decision-makers treat engineering warnings as optional. It also changed how many countries think about inspections, load changes, and accountability. Because a building collapse is not just a failure of concrete and steel, it's a failure of systems, ethics, and responsibility. If there is one lasting message from Sampoong, it's that engineering warnings must have power. A crack in a beam is not a suggestion, it is data. And when the people in charge ignore that data, the structure eventually makes the decision for them. And that brings us to the bigger lesson across all 5 projects. Construction mistakes do not just affect buildings, they affect lives. From iconic landmarks born from flawed foundations to tragedies caused by ignored warnings, these failures remind us why engineering ethics, oversight, and accountability matter. If you enjoy content about skyscrapers, megaprojects, and the real stories behind the world's most ambitious builds, make sure to subscribe to Next Build.